Welcome to our first video lesson. We're going to be talking today, guys, about circles, specifically today area and circumference. Many of the problems in these next video lessons are going to be regarding this situation. So if you kind of read along with me, Lance owns the Fly-Right company. His company specializes in making parachutes and skydiving equipment. After returning from a tour of Timberlake Gardens, he was inspired to create a garden in the circular drive in front of his office building. Lance plans to hire a landscape architect to design his garden. The architect needs Lance to provide the area and circumference of the proposed garden so the architect can estimate a budget. There's a few things we need to know about circles in general as we kind of jump into this unit, some of which you already know. We know that the radius of a circle goes from the center to the edge. We know that the diameter of a circle goes from one edge through the center to the other edge. The circumference of the circle refers to the distance around the edge of the circle. In a polygon, we would refer to this as perimeter, but technically a circle is not considered a polygon since a circle doesn't have any angles, any outside vertices, therefore we give it a separate name. But circumference is going to be this distance around the edge of the circle. The area refers to the space inside the object. In this case, the space inside the circle. And we're going to be looking at formulas for both circumference and area. Our area formula is pi times radius squared, and our circumference formula is 2 pi times radius. Keep in mind, twice the radius is the same as saying diameter, so often we could write the formula that way. Another piece that we'll be talking about in this unit is the sector of a circle. A sector is simply a part of the circle formed by two radii. So in this diagram up above, this piece right here could be called the sector of the circle. And one of the things we'll be doing in this unit is learning how to find the area of a sector. You know what an arc is from previous lessons. We're also going to be talking in this unit about finding arc length. Arc length tells you the actual distance of the arc, which means that we're looking more at a distance measured in inches or feet rather than a distance, rather than a measurement given in degrees like we've looked at before. So now, today's focus is on the area and circumference. If we come back to this problem, here is the layout of the Fly-Right company's building with the parking lot shown below. And we want to put a garden into this grassy area right there in the middle. The one thing we want to know, if the grassy area of the parking lot has dimensions 32 feet by 27 feet, we want to know the largest possible circle that will fit inside this grassy area. Now keep in mind, if you think of it as top to bottom, this could be represented by the diameter. So for example, we could have a diameter of 27 feet and we could draw a circle that has that diameter inside this. Since a diameter of 27 feet this way would be less than that 32, a diameter of 27 is going to be the largest diameter that could fit in the circle. So if we're looking at a diameter of 27 feet, remember that the radius is half the diameter, so the radius of that circle would be 13.5 feet. If I want to find both the area and the circumference, remember our formulas above. Area is pi r squared, circumference is 2 pi r. And when we plug in our radius, remember that in area we're going to have to square that radius. 13.5 squared times pi will give us an area of 572.56 feet squared. I do want to point out that your calculators have a pi button. Please use the pi button in order to be more accurate with your results rather than using the rounded 3.14. With circumference, we're going to do 2 times pi times that 13.5. Remember that by doing 2 times 13.5, we're actually getting that diameter, so we could simply do the 27 times pi. And again, using the pi button, we're going to get a circumference of 84.82 feet. Now you'll notice the units, area is again feet squared, circumference is only feet, and that's because if you go back to your formulas, in the area formula, we multiplied the radius times the radius. Both of those were measured in feet, and if you multiply feet by itself, you square it. In the circumference formula, you only use the radius once, which means you only have that unit of feet once. Okay, even though the larger circular gardens will fit in the grassy area, Lance decides that he would like the garden to have a diameter of 20 feet. The landscape architect recommends surrounding the circular garden with decorative edging. Keep in mind, surrounding that circular garden, when we're looking at this garden, that means that we are going to be putting this edging, this circular edging, around the edge of the garden. The edging is sold in 12-foot sections, so each one of these sections is 12 feet. And it can be bent into curves. We need to decide how many sections of the edging will be needed to purchase the garden. Since we're going around the garden, this tells us that we need to find the circumference of the garden rather than the area. Circumference, 2 pi r, or diameter times pi. We know the diameter is 20 feet, so if we plug in the 20 using the pi button, looks like our circumference is about 62.83 feet. Now remember that we have these 12-foot sections, so I need to decide how many 12-foot sections are in the 62. If we divide by 12, we'll come up with about 5.23. We can't buy 0.23 of a section, so when we round that up, we can say our final answer is that we'll need 6 sections of fencing to surround the garden. And that'll give us a little bit of extra in case there's some errors. Then, to begin building the garden, the landscape architect needs to purchase soil. To maintain a depth of 1 foot throughout the garden, each bag can cover 3.5 square feet of the circle. How many bags of soil need to be purchased? Show the calculations. Again, we're back to talking about what are we doing with the soil. The soil is going to be placed inside the garden and filling up the entire inside. Since we're filling up the inside of the circle, we are now looking for area this time. Area is pi times radius squared. Remember that our circle had a diameter of 20, which means it has a radius of 10. If we plug in 10 squared and multiply by pi using the pi button, we're going to get 314.16 feet squared. Now this is the full area of the garden. We know that each bag covers 3.5 square feet. So if I divide by 3.5, we'll get about 89.76. Once again, we can't buy 0.76 of a bag, so we'll round that up to 90 bags of soil. Now, Lance and the architect are discussing the possibility of installing a sidewalk around the outside of the garden, as shown in the diagram. We need to find the area of the sidewalk. Since we're specifically looking for the area of the sidewalk alone, that means we're looking for the area of just this part of the diagram. Look at the full circle in the diagram. Here's our larger circle. This one includes the garden. Here's the garden and the sidewalk. We need to find the diameter of this larger circle. Remember that the diameter of the garden itself was 20, and then the sidewalk is 2 feet. So if I add 2 feet on each side of this, the diameter of the large circle is the original 20 plus 2 on each side, or 24 feet. Now to find the area of just the sidewalk, I'm going to have to find the area of the large garden. That was the one that had that diameter of 24 feet. I'm going to have to subtract the area of the smaller inside garden. That was the one that had the diameter of 20 feet. And then I should be left over with that sidewalk space. So area of the large garden. Area of the large garden is pi times radius squared. The radius is 12 since the diameter is 24. And if I do 12 squared times pi, I'll get an area of about 452.39. Now recall that up above, we had already found the area of the small garden right up here, the area of the small garden was 314.16. So if we subtract the smaller garden, the sidewalk is about 138.23 square feet in area. Little last minute practice of just using our two formulas. And always pay attention to what information you're given. In the first circle, I have this radius of 5 inches. In the second circle, I have a diameter of 24 inches. If the diameter is 24, then the radius is 12. I want to find my area using pi r squared and my circumference using 2 pi r, but I do want to give the answers in two different ways. First, I want an exact answer in terms of pi, and second, I want a decimal answer rounded to 2 decimal places. I still want you to use the pi button so that that decimal answer is more accurate. So in looking at this one, if I plug in my radius of 5, 5 squared is 25, my answer in terms of pi is 25 pi inches squared. As a decimal, multiplying using the pi button, I'm going to get approximately 78.54 inches squared. For circumference, 2 times pi times the radius gives me a circumference of 10 pi, and again, that's an exact answer. As a decimal, using the pi button, that's going to be about 31.4 inches squared. Oops, I'm sorry, not squared, just inches. In the second diagram, make sure you're using radius when you're finding your area especially. So pi times radius squared is 144 pi. That's my exact answer. If I multiply by my pi button, I get about 452.39 centimeters squared as an approximate answer. For circumference, 2 times pi times radius, or I could just say diameter times radius, centimeters. And using my pi button, that is approximately 75.398. So that will round up to 75.40 centimeters. Your practice will be trying these problems. Please remember to show all work. These problems can be found on Schoology, and they can be submitted to Schoology with work once completed. Hope you enjoyed our first lesson, class.